Hello and welcome, Paul. Yes, this is my video for you. It's call it a Christmas gift. I've watched a lot of your videos and I've noticed that you don't wire your own guitars. That you're always finding a kit of some sort and you're putting it together in the guitar. Yeah, you're screwing it in. You're not actually wiring things. Now, don't be ashamed. I actually used to do the same thing, but then I sat down and I learned how to actually solder guitars, how to do the whole thing, and I'm a better man for it. In today's video, I'm going to teach you how to solder because you said in your video that YouTube is like the Wild West and you have to stick your neck out and, just see what happens. And I wrote you a comment saying that I'd teach you how to solder, and you did give that comment a heart. Probably because I told you that I love your videos. But anyway, yeah, I'm going to teach you how to solder in this video. And I'm calling the video How to Solder Guitars for Dummies, because if I can't teach you, then nobody can. No, seriously, it's super easy to solder guitars. A lot of people will make it seem like it's a lot harder than it is, but it really isn't. So after this, you'll know how to solder. You'll just know how to do it. Now, you can see this as my Christmas present for you, gift, whatever you want to call it. And you're getting it a little early, so you have the opportunity to tell the missus to get you a multimeter. Because you need a multimeter. Since we're both guitar builders, also guitar players, but we're both pretty bad at that, I'll tell you a pro tip. Because I know you build a lot of guitars, I also build a lot of guitars. You don't have time to sit around, testing things and going through things. With the multimeter, we're gonna use two functions. We're gonna use the continuity mode and we're gonna use the ohms mode. Now, make sure the misses, as you call them, that's not what we say here, but anyway, it gives you a multimeter that has a little speaker in it, so that when you put it to continuity, the prongs will make a sound. I don't know if you can hear it. That's a pro tip, because if you don't have the sound function on your multimeter, then you have to look over at it every time to see what readings you're getting. But if you get the sound, then you don't have to. Then you can just poke around like a crazy person, which I know you are, and get it just out of the way. Super quick and super easy. And it seriously cuts down wiring up a guitar by maybe a third or 2/3 or 3/3. If by some weird crazy reason you're watching this video and you don't know what this intro is, I'm sorry. I made a comment on one of Millhouse Studios' YouTube videos and I really like the channel. He is so fun to watch and I have been enjoying his videos the last couple of months since I found him. And yeah, he hasn't been able to teach me anything at all about guitar building, but he has made me laugh a whole lot. And actually, as a fun fact, he's the only guitar builder of all the channels out there on YouTube that I've been able to show on my phone at a party and not been unpopular. Actually, quite the opposite. I managed to get a crowd of guys around me laughing at his way of with words, if you say so. Now, he's probably not for everyone, but I gotta say, he has a heart of gold and a mouth of... Let's not go there. So if you don't know who I'm talking about and you don't know what it is, I'll link his channel below. And I think that if you have a sense of humor, you'll enjoy him, because his videos are very special way. But yes, in this video I'm gonna do a sort of how to wire guitars, and I'm gonna basically try to go through all the guitars in a somewhat way. Obviously I can't cover everything, but hopefully I'll cover enough so that if you're wiring a guitar, a Strat, a Tele, a Les Paul, something else, you'll be able to do that if you just follow my instructions. I'm also gonna hopefully get you to a point where you don't have to hit your pickups with a screwdriver and test them through an amp or something like that, because even though I don't think it's wrong to do so, and it's perfectly fine if you're at that stage where you do that. It is a very beginner thing to do, and I feel like a lot of guitar builders never get past that point when it comes to wiring. But if you just do things in a very systematical, linear way, and you just make sure, for example, that you have a multimeter, then you'll never get to the part where you're worried that you have wired up something wrong. I haven't been tapping pickups except for in videos for you guys. I've never done it on guitars for like 10 years now because it's just unnecessary. So I hope to get you to that point as well in this video. Obviously, a little bit of practice is also involved in this. You can't just watch this video and think that you're going to be like a super master of wiring guitars immediately. But yeah, watch this video and hopefully it will inspire you all. It is a gift to him because he needs it desperately, but maybe the rest of you will also enjoy it. So yeah, hopefully you enjoy it, and check out him in the description below the video. You're gonna love his videos. They are just so much fun. All right, so let's get started. We have a lot of things to cover, so we better get going. I brought out the whiteboard. It's not been on the channel for a long time now, but here it is. So we're gonna start off with some really basic things. Think of a loop, basically. The signal comes in, it wants to travel, and it wants to come back out again. So just think of a loop. And you can think of it like this. It comes in, and on its way back out again, it becomes the ground. And try to always use black for ground and maybe red or your favorite color for the lead signal, and give yourself less of a headache. So everything needs to come back out again. You can think about it like that if you want to. I know that coming back out again might sound misleading because it's not coming back out again from the guitar. Everything is leaving the guitar. The guitar is the starting point and the signal is leaving the guitar. But in a circuit sort of sense, everything is always going to ground if it's going anywhere, if that makes sense. It doesn't matter if it makes sense because it's not important. If you have, for example, a pickup and it looks something like this. 1, 2, 3, 4, 5, 6 little dots, and you have a ground wire and you have a lead wire, right? Hopefully you've seen a pickup before, which I assume you have since you build guitars. Anyway, it's actually just one wire. It just goes around and round and round and round and round and then come back out again. And you just solder on these wires because the wire that is on the pickup is so thin that you have to have something to solder it in place with. And then you have a jack, and it looks something like this. The little thing that sticks up, and it has two little connections. And one connection will be to the ring that is in the center of the jack. If you look at your cable, you'll see that it has two connections. And it has a little spacer in between, and that's there so that the two don't touch each other. And this is the ground, and this is the lead. So if you have, for example, one of these plugs, you can keep that around in the shop so you can always look at it and get reminded of this. There is never, ever any instances where the ground connection here is the lead. If that was the case, then you would have guitars that could only work in certain setups or something like that. No, this is always the ground and this is always the lead. You will have sometimes maybe a guitar that is made with stereo, but that just means that the sleeve is split into two and you have a left channel up here, you have a ring in the middle, and that's the right channel, and then you have the ground, which is the rest of the sleeve down here. So it's never the other way. So if you look at your jack, your physical jack, and the way it looks, you will see that you can follow the traces. For example, here it's very easy to see that this leg here is connected to this inner middle part here. And so it's very easy to see. That is the ground, which leaves this only to be one thing, and that is the lead. So solder your ground to that, solder your lead to that. Just like this right here. And there you have a guitar sorted up already to go. You can play your guitar like that. You don't have to do anything more than that if that's what you want. The problem is not a lot of controls here. In fact, no controls. So what you want to do is you want to find a way to just insert a volume pot. right here. And we draw it like this. A circle here and 3 little legs like that. So if we look at a pot, here we have it. Now, when we go to solder this up and when we look at different pictures, we always see it from the back. When you see someone draw it out, they're always showing the back. And that's leg 1, 2, and 3. Now, the way a pot works is that it looks sort of like this. And in here, you have a little connector thing. You have a piece of carbon of some sort and a little wiper that you can move across to different places. And depending on where you put it, you get a different resistance between the 2 legs you are measuring between. So for example, if these are the 2 legs that I have my multimeter on and it's here, maybe I'll get, let's say, 100k ohms here. But if I measure these 2 legs instead, then I'll get the rest of the pot value there. The way you measure a pot is you take your multimeter and you look for this symbol that is right there. That's the ohms symbol. On the pot, you will have it written a value. This is a 250k pot, but it might not actually be it. So what you have to do is you have to set your multimeter to the closest value of what is written on it, but the one above. So the closest but above. For example, if this had been only a 200k pot and not a 250k pot, I could have put it to 200. But since it's a 250, I'll have to move it up to 2000k, which is the closest that is above that my multimeter has. And then you take your pot, you take your prongs, and you put them on the opposite legs right here, and you get a reading. So this pot, for example, is not a 250k pot. Its actual value is 226, as you can see right there. But if I want to, for example, see what its value is at what I think is roughly halfway, there maybe, yeah, there maybe. I can go from either of the 2 legs on the outside to the middle one. There is 200, so I probably didn't move it enough. That's roughly the middle now, 119, 114. Those are the only things you need a multimeter with ohms for, because sometimes, and I'm not saying that this matters, but in some cases people do care about these sorts of things, and when you're wiring things up, sometimes you want to know the actual value of something. Pots come with a variance in them, basically. That percentage is different for different manufacturers and different brands and all of that. And sometimes you might wanna if you are working on something very, very, very special, or some very particular customer's guitar, or whatever it might be, you might want to make sure that you measure your pots yourself to make sure you really have a 500k pot in there. If you buy, for example, well, let's say a bag of 500 pots, you might want to go through that and sort the pots into what their values actually are. Maybe. Not saying that you maybe want to waste your life doing that, but in some cases, if you're selling a guitar for a lot of money, maybe you do want to. Okay, let's take a look at a pot again. So visually, to make this very easy for yourself, a volume pot basically is just sort of like a filter for your sound. It comes in through one leg and comes out the other one. And we ground one leg back of the pot so that it's grounded. And it's only because we also have maybe, for example, the pickup wires, the ground going to the back of the pot as well. Now, you can think of it very easily because you can get confused about which of these 2 legs you're supposed to ground. And the way I like to think of it is the side that you don't ground off is the side you're moving in to the middle. So if those 2 are connected, then this side, turning the pot that way, will move the signal into ground. If you ground off this leg instead, then it will be this way that you move it into ground. And you can basically just decide. If you put the pot into the guitar and you move the pot physically on the guitar as you're playing, you can tell which way you want to ground it. And there you can have a lot of different ideas about how you want to go about it. For example, if you're building a guitar for right-handed players, there is a certain way you do things, but if you're building a guitar for a left-handed player, then maybe, for example, wiring it up the opposite way works better. But then again, a lot of left-handed guitar players are used to having the guitar wired wrong, actually. So take that into an account. And basically all you're doing, because we have an illusion of volume, it's not actually a volume control. Actually, it's just your signal is being grounded. So we perceive it as being that the volume is getting lowered because it physically is, but in a sort of sense of how it's wired, like how it functions, the mechanics of it. Your signal is just getting more and more pushed to ground. the resistance is getting lower and lower and lower. And eventually it's easier for this leg to be connected to this leg than it is to be connected to this leg, because the resistance has changed in the pot. It's like turning your faucet. The more you crank it, the more water will flow through, because there's less and less resistance. And whenever your signal goes to ground, it goes away. You can think of it like that. We'll look at some more examples of that in a bit when we go to a kill switch. So we have our pickup here, and it has a ground wire and it has a lead wire, and we have a pot. We have our 3 little legs. We ground one off and we ground the pickup to the pot as well, so that they are all grounded. We take our lead wire, we put it to the first leg, or actually I think it's the third leg. It's always a little bit confusing, but on this pot you can actually see it written. Yeah, when you turn it around, I think I pointed in the wrong order before. This is the third leg. Anyway, it hardly matters. It goes in there, and depending on what you do with these controls, it changes how this goes out. And this is connected to the jack. And then we put a wire here as well. Easy peasy. I hope this is not confusing. And if it is, then you'll have to let me know in the comments below, and I'll help you out. So how do we test this and make sure that it works? Well, if we take our multimeter and we put it to continuity, which is this symbol right there. I hope you can see it. It is a little arrow with a line over it, and then it's like a little dot with some lines creating the sound symbol. Mine has a speaker in it. The way it works is when these two touch, you get continuity. Now continuity means that a current can flow through it, basically. So if I take a wire, for example, like this one, here is from a pickup, which is very good for this example. This one has the lead wire and the ground wire together under one roof. So this bare wire here is just one continuous string, right? It goes just into this plastic here. So if I hold this on one side and I hold this on the other side, I should get continuity, which I get. But if I change this around and I, instead of touching this bare wire here, I touch this here, I don't get any continuity. And that's because they're two different wires. So no sound, no reading. That's why it works well and helps out. Because, for example, if I take this pot right here and I move it all the way over here to this side, basically crank it like that. Then, if I touch leg 1 and leg 2, I should get continuity, which I do. But if I do here, the resistance is so high that I don't get it. See? But as I move this over here, the resistance just gets higher and higher. I don't get sound there, but now I get it here instead. And you can do that for example, to test your pot. If you have a pot and you're worried that it doesn't work, you don't necessarily need to use the ohm to measure it. Can be a good way to do it at certain points, but you can use the continuity mode to make sure that, okay, well, when it's all the way over here, it does give me a signal. And when it's all the way over here, it does give me a signal. It's always between one of the outer legs and the middle leg. So yeah, but we don't want to just sit in the dark and try to figure out what we've made a mistake, what sort of thing has gone wrong. So how do we do this? Well, very easily. We take our pickup, and on the back of the pickup, you will see a point where it's been soldered, and you just go through the guitar. So you have your wiring right there, and you take your multimeter, you put it to continuity, and first you can check all the grounds. You hold your prong there, and see if you get continuity. You hold your prong there and there, you check and see if you get continuity. You hold your prong there, see if you get continuity. If you don't get continuity, you look and see, is the wire actually connected? Is the solder joint dirty? And you just fix whatever it is that is a mistake. You do the same thing here. You hold your prong there, you hold your prong there. You move this pot all the way so these two legs are connected. You check and see if you get continuity. If you don't get continuity, you know that something right here is something is going wrong here. If you get continuity, you move the pot all the way so these two legs are connected. So just swirl it around, and you check to make sure you don't have continuity. If you have continuity, there's something wrong with the pot, because it's just not going to work. And that's like, I can't even begin to explain how good that is to know, because then you're not shooting in the dark. So much guitar wiring without a multimeter is just soldering things up and hoping that something is working the way it should. And then when you go to test your pickups and you're hitting it with a screwdriver and you're noticing that something is wrong, you have to just fumble around inside of the guitar trying to figure out what it is. And eventually, after going through everything and gone crazy and started to pull out your hair, and yeah, you go, I can't find whatever is wrong with this guitar, and you just realize that maybe I should check the pots and see if they're actually working. And it's better to just check everything immediately, like as you're putting them in. Just get that into your spine or whatever, to just like constantly be checking things. And the wiring will it will cut down the time, because you're not chasing your own tail trying to figure things out. You're just solving all of it immediately. So now we've wired up a guitar that has, a pickup and a volume control. And I know a lot of you would not want a tone control, but it's actually a good thing to have a tone control. If you don't use your tone control, then I've done enough videos on why you should that I'm not going to bore you about it here, but you really should. The tone control is like, I would say, even better to have than the volume control. But nevertheless, here we have a tone pot. Now, you'll have a wire going from your volume, that is down here somewhere, to the middle leg, like so. Then you'll basically have the option of which leg you want to use, and it's sort of like the volume control. You'll put your capacitor between one of the legs and the back of the pot. If you look at your capacitor, it's like a little green square. It doesn't have to be green. There are a lot of different ones, but when you open up your Gibson, it will look something like this, right? And you just solder two legs, one to the back and one to the leg. It doesn't matter which leg you use. I know people will talk about like, oh, well, the way the pot tapers makes it matter, but it's for this demonstration, it doesn't really matter, and it also is a question of what you believe. And you can mess with this. I mean, you can have the volume being clockwise wired and then the volume counterclockwise wired, depending on what you feel is right. You don't have to follow any, whatever the owner of the guitar wants, basically. And basically it's the same thing. You're sending a signal to ground through the capacitor, which will cut down on your treble side and make the signal appear muddier or darker, or whatever word you want to use. So basically, the way you can think about this is that you're using this to just introduce the ground signal back in to your main signal, and it's being filtered to ground through this capacitor. I think a lot of people, when they look at the wiring of a guitar, they get confused about this. You have your pickup over here. Let's see if we can do this. They have the pickup over here, they have the volume over here, and the volume is grounded off. Then they have their tone pot over here, and the leg isn't grounded. It is grounded, but it's grounded. The grounding is being filtered through this little capacitor right there, and the other leg is open, and they don't see the coloration of how this works. You can wire it like this, where it's connected right there. You can also, if you want to, you can have it go right here instead, like so. It doesn't matter. There's probably someone who's going to say that it does, but I've never noticed that it matters. Anyway, so when the pot is turned all the way this way, that leg is connected to that leg, and there's nothing here. So there's nothing for this signal to be introduced to, right? But when we turn it the other way, here, all of a sudden it's connected to that leg. And if you had not the capacitor there, it would be just like another volume. You would just send your signal to ground. When the signal is sent to ground, it dies. But it goes through a cap, which is filtering it, which is introducing the effect of some signals being able to pass through here, and some signals not being able, or parts of the signal, I should call it, which means that, in this case, you're losing your treble, or at least filtering some parts of it. So you get, if it filtered all of it, it would really mess up the signals. So you have to make sure that whatever value you have here is not something that is completely crazy. If you look at your capacitor, I have one right here, you will see a value written on it. And this is a 47, for example. It's written right there. You can get really into that, but it's not that hard to do. I suggest you You either just decide what value you want, go with something basic and easy, or you print out a chart where you can see what a picofarad is, what a nanofarad is, what a microfarad is, and you just you can see in the code which one is correlating to one, which is basically like, for example, a 100 picofarad is a 0.1 nanofarad, which is a 0.0001 microfarads, for example. It doesn't say anything right now because you don't get, the meaning of it, but I'm just taking that as an example. If you have a chart that you've printed out or you have on your phone, then you'll see that like, oh, well, if this is a 4,700 picofarads, it's also a 4.7 nanofarads, and it's an 0.0047 microfarad capacitor, for example. Like, it's all the same value, because you have a chart in front of you, so you can just see that, oh, well, that's like a simple way to do that. So hopefully you get it now. You'll also either have a shield. This is important. If you have shielded your cavity, then as the pots get screwed into place, you see all of this is going to get connected to that shield. If you don't have that, then you'll have to put a ground wire in. So let's just assume that you're a knobhead and that you don't shield your cavity. Then you'll have to put a ground wire between these two places. And the way that you check to see if this is working is that you take your two prongs and you see if you get continuity between these 2 points. Or if this whole thing is grounded, you can just go like that. Because the pot won't work as a tone control if it's not grounded. Does that make sense? Good. And then you'll obviously have your two wires coming off. You'll have the ground wire coming off here or here, it doesn't really matter. And they will go to the jack. They'll go like that, and then you'll have your inner ring connection and then your other connection, which is the lead, like so. So quickly, before we move on, there is one more ground connection that we have to talk about. It's super important, and it's the bridge. Depending on what sort of guitar you're building, at some point you'll have to install a ground wire. If you have a Stratocaster, and here I have almost a Stratocaster bridge, I picked it up and didn't realize no saddles. Anyway, this one has springs on the back that goes to a little claw, and if you look at that claw, you'll see that there is a ground wire there. You have to just put a ground wire there. It's usually soldered in place, and then it's pulled all the way through the guitar and soldered to the back of the pot. If you have a Les Paul-like guitar, you'll have this for your bridge. It's an end piece and the bridge, and they are mounted in the guitar through holes that are drilled into the body so that the little studs can be pushed into place. And you just have to, before you put those studs in, drill a hole into another cavity somewhere. And a good thing is to get yourself some of these longer drill bits that I have right here, I think. I think this is like a 2 millimeter or something like that. And you just, you just have to drill a hole, pull a wire through, expose the bare wire, and make sure it gets clamped in. Now, this is where the multimeter will come very much in handy, because you can just take the other end of the wire. You have the wire and you have the bare wire sticking out on the other side, and you just take the multimeter, you move it to continuity, you put one prong on the bridge or the stud, and then on the other one on the bare wire, and if you get continuity, it's all good. If it's not, you're gonna have to pull that stud out and redo it and make sure you get continuity. And it might sound terrible to have to pull the stud out, but you would have to do that anyway at some point if you haven't gotten continuity. And isn't it nicer to just get that out of the way immediately? So you just use continuity to make sure you have connected your bridge. On something like a Telecaster, depending obviously on you're actually using a real Telecaster pickup and not a weird other kind of pickup, it will have a plate on the back of the pickup. You can see it. You turn the pickup over and it has a plate on it. And the bridge is actually getting grounded to that plate and grounded to the bridge through the screws that are going through the bridge into that plate. And the reason why it works even when you're not playing the bridge pickup is because the ground wire is connected to the pot and not to the switch. And so it's always getting that ground connection no matter what. And both pickups grounding are at the same place, even if they're not soldered in the same exact location. Which, I mean, they usually are, but even if you weren't going to do that, all groundings are supposed to be connected to each other. All right, so now we're moving on to switches. I'm going to try to briefly look over this, but it can get a little bit complicated and a little bit hard. This is probably the hardest part of wiring up a guitar. Let's try to simplify it a little bit. So, basically, when it comes to guitar building, you will almost never encounter something that isn't a mechanical switch. What that means is there are metal plates that are moving and they're making connections, and when something aligns, the signal will be able to pass through. And it's a mechanical thing that is moving, and it's not something else. There's nothing magical or weird or something going on. So let's take a look at a couple of switches. Now, what's good about these switches, in most cases, is that you can sort of just look at them and understand how they work. Some of them are sealed in, so you just have to know how they work, but I'll tell you how they work. So let's start with a Les Paul, because a Les Paul is really easy when it comes to the switch. So here we have a Les Paul switch for a more inexpensive sort of budget guitar. A lot of people will say that these switches aren't good, but they don't have to break just because they're in an inexpensive guitar. And if you need to open it up, you just lift these four legs. The way this works is that there is like a little arm in here that continues the pull from this and connects the legs in here. And whatever you do, the signal will always be connected to the middle leg. So when it's pulled like that, it's the opposite side because it continues through it like an axle right here. So that one is connected to that. Pull the opposite side, that one is connected to that one. And when in the middle, both are connected. It's just a mechanical little thing in here that you can't see because it's enclosed. So that's all you have to know about one of these switches. There's nothing special about them in any way. Some switches we'll look at later will be exactly the same, but without the middle thing. So just think of that. Whatever this is, pull to whichever side, opposite side is where it's connected. So if I were to put this in a guitar and this was facing towards me, then that would be the leg for the neck pickup. And then as I pulled that away from me, I would connect that leg to the bridge and then both to the middle. Okay, if we look at a switch that is maybe a little bit more common in a Les Paul or a little bit nicer, depending on how you look at it, you will notice that this is the opposite way around. You have four legs. This is a ground leg, and you can tell because you can see that it's connected to the rest of the switch. Whichever leg is connected to the rest of the switch, like up here where the mechanic for screwing it in place exists, that leg is always going to be the ground leg. Then you have four legs here. They're usually thinner. This one is pretty thick. And two of those are getting sorted together in the middle because of how this is whole put together. They're just the leg for each side. And if you look in here, you can actually see as I'm moving this, I don't know if you can actually see it in the video, but you will definitely be able to tell when you're holding the switch in real life that it's not about connecting the legs. It's about removing the legs. So when I push it here, that plate there is getting lifted away from that inner plate. And that inner plate is connected to these two legs, which means that I have to think opposite. That when I do that, that is my leg. So if I had this like this, for example, and pushing it towards me, like you would do on a guitar, that would mean that this leg here is still connected to the middle, as you can see in there. So that's where I connect my neck pickup, and as I flick it down there, that's my bridge. And in the middle here, both would be connected to the middle, because you can see both plates are touching the inner plates. And if you want to check this, again, you just have to take your multimeter, put it to continuity, which I know, like seriously, I can't stress it enough how important it is that you have continuity mode. And I just see if I get a beep. I do. Yeah, on both. And then if I flick it, I'm moving one of the plates away so it's not mechanically touching. And as you can see, those two still, but not these two now. Super easy. And that's why you need a multimeter with continuity mode, preferably where you also get the sound. And this is super easy. We'll look at the Les Paul wiring because I just want to put a thought in your head to make a Les Paul easier. Here we have a switch. There's some wires on it because I pulled it out of a guitar. And you can actually, if you open this up, you'll see that there are like a little comb-shaped metal thing that is getting moved around with the switch. And this works exactly the same way. When I pull it there, the combs are touching that way, which means this one is connected now, and as I move it, these two are connected. And as I move it, it's only that middle one there, and as I touch it here, it's those two connected, and there it's only that one connected. And it works the same on both sides. And then you have them connected to the middle. So these three connections here are opposite. So let's say that this is my, if it's in like that, for me, it would be, because I'm left-handed, maybe I should have said, don't know if you've noticed, then that's connected. So let's say that this is my bridge, then that's my bridge, and that's my middle, which is obviously the middle of these three, so it's not that hard. And then that is my neck. And they will all be connected to this leg here, and then I can solder whichever one of these I want to corresponding tone control. So for example, if that's my neck, then that's my neck tone, that's my middle tone, that's my bridge. That's usually not used for anything because you don't usually have a tone on your bridge. And that's also important because that means that you can take the tone out. We'll look at an example of a guitar that I am actually building later, and you'll understand what I mean. But if you have the tone on a switch, you can remove it from the circuit. There is a debate, or whatever you want to call it, going on where people are talking about, like, if you remove the tone out of the circle. Well, actually, you've had a guitar for 70 years or whatever that can do that, and that is the Stratocaster. If you put it in bridge, you've taken the tone control out of the circuit. It's not connected to it. It doesn't matter what you do because it's physically taken out. There's no signal going to it. Anyway, here we have a Telecaster. I don't have a Strat, one of these right now. But if you look at it, you can see how it works. And it might be confusing, but it really isn't. It looks more complicated than it is. But basically you have two switches in one. And as you look at this, you can see that this leg is always connected. Wherever I put it, it's always connected. And you can check it with a multimeter. Put it to continuity mode. Again, if I hold it here and I put it there, I get continuity. If I push it there, I still have continuity there. And there, I still have continuity. So, depending on what you want to do, you can wire this up differently. The weird thing is that you have the same switch in opposite direction on the other side. And so you can bridge the two connections on both sides to give you a possibility of when it's touching, it might be able to connect both of them together. So for example, if I were to wire this up to be a Telecaster, I might put the signal going to my volume here. Instead of letting it go directly from my pickup to my volume, I'd splice this in between. And I put the signal here, and I put my bridge pickup here. I look at what leg this is, so it's that. I'd connect my neck pickup there. And then I just bridge these two legs so that when they are touching, they are connected through a wire. And then by pulling them together, I can move the switch and bridge the two sides. I hope that makes sense. If it doesn't, it will make sense once you look at the switch yourself and you use continuity mode to actually see the physical change that is happening. Okay, the same thing goes with these switches right here. This switch you'll see in a lot of modes. For example, if you're maybe doing something where you're turning a pickup on or off, or if you want to do the mode where you're cutting out your tone and volume control out of your guitar on, for example, maybe like a Strat or something, and you want to take them out of the circuit, you can use one of these switches for that. I'll show you in a second. This switch here and this switch here are the same switch. The only difference is this is one switch and this is two of these switches in one. If you look at it, you can see that it has a line in the middle that is dividing it, and that's because it's two of these. These are not connected to each other, two separate switches. So if you look at this, it's the same thing here. It has two modes, and basically depending on where you put it, it's either of these two legs connected to the middle there. When it's like this, those two legs are connected. When it's like this, those two legs are connected, but something is always connected to the middle. So for example, if you have a Stratocaster, you'll have a wire going from your switch that you select your pickups with to the volume control. And if you cut that wire and you splice this in, putting either of the sides to the middle leg and the other one to either of the outer legs, then you can basically turn the pickups on and off with this switch. And then if you put on the opposite side, for example here, a wire going to the output jack, then you can basically select if you want your signal from your pickups to go the standard way to your volume control and then to your jack, or if you want to bypass the whole thing and only have it go directly to your jack. Same thing, if you do the exact same thing but you do it with one of the tone pots, you can basically turn off a tone pot, take it out of the circuit, or leave it in. Super simple, easy mode. One of these switches, and I'm gonna take the whiteboard out for this because it might get a little bit confusing. You can wire up be a phase switching. Now, what that means is that you're basically changing which of the wires from your pickup you're using as the ground wire and which one you're using as the lead signal. If you have your switch right here, it looks like this. You have your 6 little legs like this. If you think of it like that, it looks like that. You will have your pickup come in here to this leg, and you'll just solder your like so, and then you'll connect your wherever the pickup is going, if it's your switch or if it's going to the volume directly there. So when it's flicked like this, pickup is connected to the middle. If we flick it like that and we connect this one over here, crossing them like so, then when we flick it, your pickups will go not from being connected like that, but connected like that, which means it will be connected to the opposite. Basically just flipping them around. It's a very simple and easy mod to do. You have to make sure you put it in between the pickup and wherever it's going so that you don't mess up. So for example, here we have our pickup and its wires are coming off, and here is the switch that it's going into, and here are the 2 wires coming out, and here is my volume pot, and it's getting connected to the legs just like in the beginning of the video. And if you have, for example, a switch, that would be maybe here, for example. If, for example, we say we put this into a Strat. That's a very easy, simple little mod that you can do. Another super simple, easy mod you can do is you can install a kill switch. It's very easy to do. It's probably the easiest mod that you can find. What you need to do is you need to find a switch that you can check with your multimeter. Put it to continuity and you hold it to the legs like so, and you don't get a sound, but then when you press it down, you do get a sound or a reading. But I strongly suggest you get a multimeter that does the sound thing because it makes everything easier. And all you have to do is you just have to put one wire that is your ground wire and one wire that is your lead wire. It doesn't matter which side you choose for what, it doesn't matter. And then you just have to find a place on your circuit where you can put it in. The ground wire goes where every other ground wire goes. So for example, on the back of the pot, just solder it there like everything else. And then, for example, on the in or output, you just solder the lead signal. And all it does is doing the same thing that I've said throughout the video. It is bridging the connection between ground and the lead. And whenever that happens, your signal dies. So it's basically just the same thing as a volume, except a volume, you can gradually do this. And we interpret that as lowering the volume. And here you're instantly killing the signal over and over again. And if you have a switch that has a little bounce where you have to press it down, because there are switches that, won't do that. You can, for example, you could wire one of these up. You can just split your signal wherever you want it, your lead signal, just split it and put one of the connections to the middle and one of the outer ones, like this, for example. And then just add a ground connection to the last one. Then you'll have a on-off switch for your guitar, for example. A lot of people don't use their volume or tone control, so they don't necessarily need to have a tone control and they don't necessarily need to have a volume control. But having, for example, a little switch that lets you turn on off the guitar could be really useful, especially if you don't do anything subtle. You just go all or nothing. And I honestly think there are a lot more guitarists that would benefit from having one of these switches than having an actual volume control. Then there is one more thing before we go into a little bit difference between the guitars. And that is you can actually wire up a tone control that is cutting bass instead of highs. And you have to do this a little bit different. You have a pot. Usually it's a tone pot that you're sacrificing for this. And you have your 3 legs like this. And you put the signal that you're gonna go to your jack. So this wire is supposed to go to your jack, but instead you put it to a pot like so into the middle leg. Then you solder on either side a wire that goes to your jack, something like that, and then a ground wire as well. And then you bridge these 2 legs with a little capacitor like so. And here you have to use something else because you can't use one of these big 40 2.7. You need to use something like a 2.2 nanofarads. I'll just write it right there. You're most likely not gonna experiment with this too much, but somewhere around there you can experiment with it a little bit if you want to find what you want to. And the reason why is because higher values, you know, like 47 that I showed you, will remove the treble, but the lower values like a 2.2 will remove the bass. So if you have a muddy pickup, this is maybe something you want to do. But you don't want to send the signal to ground. You want to send the signal through the capacitor. And I'm not going to go into why that is because it's not important, but just know that. You can actually do this on a pickup immediately if you don't want to have a controller for it. For example, you can just take your pickup like this and take your two wires like so. You can just splice in your little 2.2 capacitor right there, and it will do the same thing. Obviously, then you won't have a controller. But if you have a pickup that you really think sounds bad because it's too muddy, you can clean it up this way. One of those, you know, you can get 100 of those for £1 or whatever. So take that with a grain of salt because I don't actually know what things costs in the UK, but you know what I mean. Like, it's cheaper than new pickups. So one last thing before we go to a practical look inside of an actual guitar so that this stops being so theoretical. Let's say that we're wiring up a Les Paul. One way that I like to think of it, now, you can wire things differently. There is something called the vintage wiring and the modern wiring when it comes to a Les Paul. But if you want to nerd in on it like that, and then you can just Google and you'll find like a diagram of how to wire it, and you will be sorted. But one way to think of it is if you wire up a Telecaster, you have your pots like this. Sorry, this drawing is a little bad. This leg will be grounded off, and this leg will also be grounded off, but through your cap. This middle leg will be connected to the leg, the in leg that is going from your switch, which is here. That's your switch. And from your switch, you will have your two wires going to your pickups. So here you have a little switch, and depending on what you do, that's where it is. Then you'll have the pickup wires ground connected to the back here. You'll have a ground connecting the pot as well, unless you're grounding it through shielding, which you are because a Telecaster has a metal plate, so it's naturally always grounded through the plate, unless you've for some reason made a wooden one or whatever. And you have one going to the bridge, and then you have one going to the jack, where this one is meeting up the jack right here. Something like that. That's a Telecaster in a nutshell. And I just realized it's a little bit out of view. Right? You have your pickups, your switch, selected them, going to the volume, going through the volume, going through the jack. You have a tone pot that you can move about. You have a bunch of grounding wires because everything is grounded. Super easy. Everyone knows how to do this. Well, let's say you wire this whole thing up twice. Something like this, maybe, unless I've missed something. And then you just have to remove this ground wire here a little bit. Remove this switch here and these pickups. Wired up two Telecasters, and we take our switch here and we wire up not our pickups to the switch. What we instead do is we're wiring our pickups directly to the pots. So our neck pickup right there goes to the upper row, and our bridge pickup goes to the lower row right there. And our ground wires go to our pots as well. And then we have the switch over there. It's all alone up here. And instead of doing it that way, what we do is we wire output not to the jack, but we wire that to the switch, like so. And then we wire the switch, the collective of it, you know, the middle leg of the switch, whatever it is, that to our jack. And then we basically have two Telecasters that are single coil or single pickup wired, and we have a switch that let us select which of the Telecasters we want to select. That's how I like to think of it when it comes to wiring up a Les Paul, because a lot of people will think of a Les Paul as something hard to wire up. But if you know how to wire up a Telecaster, then you know how to wire up a Les Paul. You just have to do the same work twice. Then you need to have a ground connection, unless you've shielded your cavity, and you just connect this one to that, and that one to that, and that one to that. Don't connect those together, because then you'll get a circle, and that will create a little bit of craziness in the guitar. So think of that. And yeah, like if you think about it, a if you learn how to solder a Telecaster and you sort of get that in your like backbone or whatever it's called to really know how to do that, then you know how to solder a Les Paul because it's just the same thing. And you know how to solder a Stratocaster because it's the same thing. The only thing that is different is that the switch works a little bit different, so it's, you know, it's adding 2 more positions because you have a third pickup, and you solder the wire going back to the volume control from the tone puts. You're soldering them directly to the switch instead of directly to the volume. You can still do that if you just want to have 1 tone pot and not 2, and you don't want them to be different depending on which pickup you're using. But you basically know that it's just a little bit of a difference. And the same thing goes here. I mean, this is how I would wire it up, but you can do it a little bit different as well here. I have a guitar that I'm working on right now. I'm waiting for a couple of parts, so I'm taking it a little bit slower than usual. That means the guitar is open, so we can take a look inside and see if we can't just figure this out. All right, let's take a look and see if we can figure this out together. So this is obviously shielded and is obviously Les Paul. Now, here is a thing that I want to point out. It's a little bit different than what I just showed you, and that is I don't have this controller here connected because I'm doing an experiment on this guitar, seeing what happens if I don't have a tone for my bridge pickup. And that's why it's not soldered in place. You'll see that I have some yellow tape, and that is because one thing that happens when you put one of these pots into a shielded cavity is that these legs here can touch the shield, and that will mean that they all get grounded. So you have to put something on there. That's something that I've never really seen anyone talk about in a video, but it is actually important. So that's why you see some tape. Anyway, the reason why I have different size pot is because the size of the pot is not what dictates the quality. The bigger the pot is, and this is not the biggest pot you can get way bigger pots than this. If you think of this as running a marathon, if you look at, the Olympics or something when they're running, you can see that they're running in a curve and the lines are drawn out. If you look at the starting, you can see that they are starting in a line and they're not all starting at the same place. They're curved. And that is taking the curvature into matter so that they are calculatedly running the same distance. And it's the same thing going here. If you measure, the radius here and the radius out here, the distance between 1 and 2 will be increased. Now, why does that matter? Well, it matters on a big pot versus a small pot because if you're trying to find the spot in between 1 and 2 where you just love to play guitar and have that just a little bit of rolled off volume or just a little bit of rolled off tone, it's going to get harder and harder the smaller the pot is to find that spot, and it's going to get easier the bigger the pot is because you just have more space to find the middle. If this is the space you have to try to find in between, you have to be really precise. But if it's this big, the space in between is not that hard to find. So that's why guitarists and guitars, they come with the bigger size. And that's what we consider to be guitarists need something to compensate, apparently. I don't know. But it doesn't matter. The quality is in the measurement. When you measure a pot and you find out its actual tolerance. Like this is a 250K, but as you saw when we measured it, it was a 226 or whatever. So, that's how you see it. Now, in this guitar, I've done that. I've chosen the smaller pots for the volumes because when it comes to Les Paul, the controls I find are kind of out of the way and hard to get to. So if I'm going to use the volume, it's going to be all or nothing. But I have a big pot for my tone. And the reason why is I like to mess around with the tone and I usually move it about. And so I need a more precise pot for that so that I can find that in between. I just wanted to get that out of the way because it can very easily start a debate. So we take our multimeter and like we always do, we move it to continuity. Continuity. So on the side here, my jack is, and here is a tip. If you want to make yourself a tool to make things easier for yourself, you can build a little box like this. It's just 2 nails into a piece of wood and a jack mounted. And as you can see here, they're just soldered in place. That means that if I, for example, use continuity mode here and I hold it to the plus, I should get a signal to the tip, which I do get. And if I hold it to the minus, I should get a ground. Minus and ground is the same. So I can, for example, plug this in here like that, and I can hold to the minus and touch the shield and see that I get a continuity. I hope you can hear the multimeter. It's not in front of the mic, but there it is. If you don't want to build something like that, you can use one of these and do the same thing. If I plug this in, it's a little out of the way there, then I can see that this is the tip and this is ground. And so if I hold this here, I can get the ground signal. So we want to make sure we have our grounds. We can hold it here to the ground on the jack, and we can go through and touch things. Like here, for example, we have the shielding wire or the ground wire coming off the jack. Good, it's connected. Here we have the tone. Is that connected? Yes. Here we have the volume. Yes. There's the next volume. And here's the non-existent pot. Yes. Here's the shield. Here's another ground wire. Here's another ground wire. And then up here, which I hope you can see, we have another cavity. I've soldered a wire in place here, going all the way to here. You can see it right there. And that is just a ground wire connecting these two. If I flip the guitar over, I have my bridge right there. So if I hold my jack, hold it to the jack right there. Everything is out of the way. Oh, did I just scratch the top? Damn it. And then I touch the bridge. I get a ground connection there as well. I don't know. Can you hear that? I know now that everything is grounded. I can touch the bare side of the switch, which is this middle connector here, the thicker one, to the side as well. And see that I get a ground connection. Just out of frame. And I can do the same thing with the switch. For example, I know that this is the lead signal. So I'll plug something in to the jack and I'll hold the continuity to the plus on this one, and I can touch, for example, the switch up here. I know I used the yellow wire to connect my switch to the output jack. There we go. And if I flick the switch to the neck, I get continuity. Damn, I'm out of frame again. If I touch it to the neck, it's there, and if I touch it there, there's nothing. If I flick the switch to bridge, then I get continuity again. That's good. I can do the same thing passing the switch. So if I put it back to the neck pickup and I hold one at the neck and I touch this back here, I get continuity. And I flip over to the bridge and I touch the bridge, I can see that I get continuity here as well. And if I go over here, I'm going to see if I can do this without dropping the entire guitar. If I move the pot all the way towards this side, the ground should be connected. I can test and see if I get continuity, which I do, and the signal goes to ground. If I move it all the way opposite way, turning it that way, I get continuity that way. I hope you can see what I'm doing. And all my math is correct, or whatever you want to call it. It's not math, but yeah. And I don't have to, oh shit. And I don't have to poke at the pickups and smack them around or anything. Well, there you have it. I hope this helps and that you now know how to solder a guitar. And honestly, all you need is a multimeter with continuity mode. I keep telling people that they need a multimeter, and it's like the best tool out there. You know, you'll save yourself so much headaches and heartaches and I don't know what else. I really recommend you just going through the guitar as you're wiring it up, instead of wiring it up and then trying to figure out what you did wrong. And like, for me, it was a game changer, just starting to use a multimeter and just going through with the continuity mode and just checking everything and just measuring things. And you'll start to see things that, like, oh, I can tweak things. You can wire in little trim pots into your guitar that lets you tweak the tone and volume pots so that they have the exact value you want them to have. Or, you know, you can wire in a trim pot at the back of your pickup so that you can tweak the tone of the pickup and get it to sound exactly the way you want to. There are some more mod things that you can do, like add, you know, different resistor values to different things, and all of it you can just measure and make sure it works with a multimeter. So yeah, you must obviously have a multimeter because you have a lot of tools, but come on, Paul, don't be a twat, I think it is you guys are saying. Yeah. Seriously, guys, I hope this helped the rest of you as well. I made this video for Paul because I see him over there struggling with the wiring parts of guitars. And yeah, I personally know that I've made a journey when it comes to guitar wiring. I went from being scared to wire guitars to thinking it's maybe the most fun part of it. and it's honestly just because I decided to invest in a multimeter. And I don't even have like a good multimeter. I have like a crappy hardware store, closest thing I could get, cheapest thing, you know. There are better multimeters out there. At some point I'm going to invest in like a really cool multimeter that has everything they could ever hope for in one. And I know that for a fact that some of you guys out there are here for pedals, and if you want to build pedals, you definitely need a multimeter. Holy crap! Like I think maybe that's why I got a multimeter actually, because my first pedal I just couldn't make it make sense at all. Holy crap! At some point I'm gonna make a video telling you the horror story of my first pedal, but it's not today. Anyway, if you haven't checked out Paul's YouTube channel, I'll link it below. I honestly really like his channel. It's probably my favorite YouTube channel at the moment, at least. Or few people make me laugh like he managed to do. So, and he has a heart of gold. You know, like he might seem like a big tough ruffian when you watch his videos, or maybe he just seemed off. I don't know, but he's clearly a person who cares about others very much. So yeah, until next time, don't forget to stay awesome and cool. And in the spirit of Paul, check up on your mates. You know, give them a ringer, as he would say. Don't text them. Make sure they're all right. You never know how someone is feeling until you actually ask them. So do that. I'll see you guys in the next video.